Page 2 of the Chapter 5 sample test starts with this one. So it says 2 times the, to what power do we take 2 to get 1/16? Well, 1/16 is 16 is 2 to the 4th, so 1/16 is 2 to the -4. So the power I take 2 to get 2 to the -4 is -4, so I get, or I can bring the -4 down, so I get -8, and then the log base 2 of 2 is just 1, so -8 is the answer for that one. Next one says e to the ln, which is log base e, of 0.35, and so these are inverses, and so I just get 0.35. Next one says, to what power do I take, and there's no base on that, so it's understood 10. So to what power do I take 10 to get 10 to the square root of 5? And the answer is square root of 5. These are inverse operations of each other. Number 3, solve this. Well, 8 and 4 are both powers of 2, so I could say 8 is 2 to the 3rd, and 8 is to the 2x plus 1 equals, and this is 4 is 2 squared, and that's to the 2x. Same bases, so the powers must be equal. And when I have a power to a power, I multiply. So I'm going to get 3x, or 6x, excuse me. 3 times 2x is 6x. 3 times 1 is plus 3. Equals 2 times 2x is 4x. If I subtract 6x from both sides, I get 3 equals -2x. I divide by -2, and I get x equals -3/2. Next one. Since the x is in the log, I convert it to a power equation. So this says the square root of 3 to the 4th is what x is. But the square root of 3 is 3 to the 1/2 power, and we're taking that to the 4th power. So half times 4 is 3 to the 2, which is 9. And 9 is positive, so we can use it. So I can check my answer. It does check, and so 9 is the correct answer for x. Next one. I have log base 10 and log base 10, except that there's a 2 here. So I better put the 2 up as a power, and so I get 7x minus 12. Log of that, let me write that in there, log base 10 of 7x minus 12 equals log of x squared, putting the 2 back up as a power. Now they're both in log, so these parts must be equal, so I have 7x minus 12 equals x squared. And so I'll subtract 7x and add 12 to both sides, so I get it equal to 0, and I get x squared. Now I could have subtracted x squared, but I like factoring with a positive x squared, so I'm going to subtract the 7x, add the 12. This is a quadratic, that's why I got it equal to 0. And I could factor, I could use the quadratic formula, but I'll go for exact answers. And if I can factor it, that'll be the easiest. And let's see, to come up with negative there, and I have to add, so I'm going to guess that if I do x minus 3 and x minus 4, I'll get negative 3x and negative 4, it's just negative 7. And a negative 3 times a negative 4 is 12, and an x times an x is x squared. That works. If I set those equal together to each other, I get x equal to 0. I get x equals 3 or 4. And I working with a log equation, so I need to check my answers. If I put 3, 7 times 3 is 21 minus 12, that's positive, and 3 squared is positive, so I can use 3. 4, 7 times 4 is 28 minus 12, and 4 squared is 16. That should work also. So both of those are answers. And they both check. And then finally this one. I have unlike bases, and I have a 5 here. Now what am I going to do? Well, I can do a change of base to base 10. There's other ways to do this, but I'm just going to say 5 is 10 to the log. You guys like log better at base 10 and then ln, so I'll do log 10 to log base 10 of 5 is another name for 5. 2 is 10 to the log 2, and that's to the x plus 1 equals, and 3 is 10 to the log 3, another name for 3, and that's to the x. So when I've got the same bases, I can say the powers are equal, but I got a multiply here, and that means I should be adding these powers. So I can write that it's log of 5, that's in base 10 now, plus, when you multiply, you add the powers, and I have to multiply the log 2 times this, so I got log 2 times the quantity x plus 1 equals, and I multiply the powers here, so I got x log 3. Alright, this is just a number. This is going to be a number times x, and then a number. And this has got an x on it, so I'm going to move those over. So I'm going to rewrite this, first distributing that. Log 5 plus x times log 2, and then times the 1, so that's going to be log 2 equals, and this is x log 3. So I'm going to subtract x log 2 from both sides. So I'll have log 5 plus log 2 equals x log 3 minus x log 2. Now I have all my x's on one side, and I'm going to factor out the x, and so I'm going to get x times log 3 minus log 2 equals log 5 plus log 2. And now I would find x by just dividing by log 3 minus log 2. So I'm going to move that over to here. So I'm going to have log 5 plus log 2 divided by log 3 minus log 2. And that is what x is. But that can be simplified. Log of 5 plus the log of 2, since it's adding, we can turn it into multiplying, so that would be log of 10, and this is minus, so we divide, so that'd be the log of 3 divided by 2, and the log of 10 is 1. To what power do I take 10 to get 10? That's 1. So I can reduce this to 1 over the log of 3 halves, or 1.5. And that looks a little bit simpler. That's page 2.